Okay, so I'm past my 7 p.m. deadline, sorry, but I was almost done and I now have to start over. So here we go. Your first question on your quiz today was tangent of z, and it's asking you for a ratio. And so that simply means that you need to leave this as a fraction. Okay, so you're leaving it as a fraction. So tangent of z, we're looking at this angle right here. Okay, and the tangent of z we know is the opposite leg over the adjacent leg. So the opposite of z is 20 because that's the one piece that is not touching the angle z. Okay, and then the adjacent leg is 21. It's this one right here. Excuse me, this one right here. So that's the adjacent, and the opposite is the side that's not touching. Now, we cannot reduce 20 over 21, so you would simply say that the tangent of z equals 20 over 21. Now, question number 2, cosine of x. Well, we know cosine means adjacent over hypotenuse. The hypotenuse is directly across from your 90-degree angle, so 50 is going to be your hypotenuse. And the adjacent leg is the leg that's attached to the angle. Now, if our angle is x, then the side that's attached to the angle, or the leg that's attached to this, or adjacent, which means next to, is xy, which is 14. So cosine of x would be the adjacent, which is 14, divided by 50, the hypotenuse. And if we reduce this, you get cosine of x equals 7 over 25. Okay, sine of A. This is our angle, and we know sine means the opposite leg over the hypotenuse. The hypotenuse is directly across from our 90-degree angle, which is 30. The opposite side is the side that's not touching A, that's opposite of A. Opposite of A is 18. Now 18/30ths can be reduced. You would reduce that and say that sine of A is equal to 3/5. Cosine of Z. Cosine of Z. This is the angle we're looking for, or this is the angle that we're finding the ratio for. And we know cosine of z is equal to the adjacent leg divided by the hypotenuse. Again, the hypotenuse is across from our 90-degree angle, so the hypotenuse is 40, and the adjacent leg is the leg that's touching our angle, z. So touching our angle is 24. So when we reduce that, we get cosine of z is equal to 3/5. Okay, questions 5 through 8, finding the measure of an indicated angle to the nearest degree. Okay, so we're actually looking for an angle, and when we look for an angle, you have to use the inverse functions. Now our inverse functions are going to be the inverse of sine, the inverse of cosine, and the inverse of tangent, depending on the relationship of the sides that we have from our angles. Okay, so if we have question number 5 here, we're looking for this angle right here. So you need to name it, I don't know, I would name it, let's be original and name it x. So if we are looking for this angle, measure of x, we have to look at what sides we're given. Well, the sides that we're given are this side and this side of our triangle. And in relation to x, what sides are these? Well, the one that's across from the 90-degree angle would be the hypotenuse. So 19 is our hypotenuse. Now 17 is adjacent to our unknown angle, so we're given the adjacent side and the hypotenuse. And if we're given the adjacent side and the hypotenuse, we know we need to use the relationship of cosine. So we have cosine of x is equal to the adjacent side over the hypotenuse. Okay, so we have cosine of x is equal to 17 over 19. And if we're looking for an angle, we have to use this inverse function. So we know that x is equal to the inverse cosine of 17/19. Okay, so if you put that in your handy dandy calculator, because you can't do that without a calculator, you would get that this angle is 26.5, but since we're going to the nearest degree, we would round that to, we have 26.5, and if we're going to the nearest degree, you would round this up to 27 degrees. Okay. Looking at question number 6, this is our unknown right here, so we're going to call this our x, and what do we know? Well, we're given this side here, and we're given this side here. Okay, well, this side of 53 is across from our 90-degree angle, so we know this is our hypotenuse. The opposite side, or this side here, 47, would be our opposite side. Okay, so this is our opposite side. So if we have our opposite and our hypotenuse, we should be using our sine function. So we have sine of x is equal to the ratio of 47 divided by 53. So the inverse sine of 47 over 53 is equal to x, which is 62.47, which would simply be approximately 62 degrees, because with it being 62.4, we're not rounding this number up to a 3, we leave it. So it's at 62 degrees. Okay, question number 7, this is our unknown, so we're going to call this x, and the sides that we're given are this side and this side. Okay, well, this 30, this side here is our hypotenuse because it's across from our 90-degree angle. This other highlighted side over here is not touching our angle, so we know this is our opposite side. And so if we have an opposite and a hypotenuse, we're going to be using that sine function again. So we have sine of x is equal to the opposite side over the hypotenuse. Sorry about that. The hypotenuse. So we have sine of x is equal to opposite, which is 27, over the hypotenuse, which is 30. And since we're looking for an angle, you have to use the inverse sine function. So we have x is equal to the inverse sine of 27 divided by 30. And if you substitute that in your calculator, we get, this is 64.158. And since we're rounding to the nearest degree, this is approximately 64 degrees. Okay, question number 8. We're looking for this angle here. This is our unknown. The sides that we have are this side and this side. Okay, it happens that the side 56 is across from our 90-degree angle, so we know this is our hypotenuse. The other side that's highlighted is not touching our angle, so this would be the opposite. So once again, you're using that sine function. So we have that the sine of x is equal to the opposite side over the hypotenuse, which is going to be 14 over 56. So we're going to look for what that angle is. So we have x is equal to the inverse sine of 14 divided by 56, which would be 14.4775, so that would be approximately 14 degrees. Okay, because again, if you have 14.47, we're looking at the tenths place when we're rounding. Okay, and if we're looking at the tenths place, then this 14 would stay at 14 because 4 is less than 5. Okay, questions 9 and 10, you're solving for a missing side. we're going to be using proportions here. Okay, this is the angle that we're given right here. It's this angle right here. And the sides that we have, we've got this side and this side. Okay, so across from our 90-degree angle would be our hypotenuse. We're not given the hypotenuse. We're given the opposite side and the adjacent side. So if we're given the opposite side, we're not given the adjacent side, we're looking for the adjacent side. So we're given the opposite side, we're looking for the adjacent side, and we're given an angle measure. We have to figure out what relationship we can use. So here, with opposite and adjacent, we know it has to be the tangent function. So we have that tangent of 72 degrees is equal to the opposite side, which is 35, over the adjacent side, which is x. Okay, you can put tangent of 72 over 1, make it a proportion, and if we cross multiply, because that's how we solve proportions, we get x times tangent of 72 is equal to 1 times 35, or 35. And then we would divide both sides by tangent of 72 degrees. So our tangent of 72s would cancel, and we get that x is equal to 35 divided by tangent of 72, which is, we're rounding to the nearest tenth here. So we got this as a 11.37, and if we're rounding to the nearest tenth, we look at the number to the right, which is greater than 5, so this would be 11.4. Okay, the last problem, we're given this angle here. The two sides, we have our this side here and this side there. Okay, across from the 90-degree angle, we have our hypotenuse, which is 27. The other side that we are actually looking for is attached to our angle or adjacent to our angle, so that's going to be our unknown. And so if we have a relationship between the adjacent and the hypotenuse, we know we're using cosine here. So we have cosine of 48 degrees is equal to the adjacent side, which is x, divided by the hypotenuse, which is 27. Again, you're going to want to just put cosine of 48 degrees over 1 so we can cross multiply. And when we cross multiply, we have 27 times cosine of 48 degrees is equal to x. And we have x completely by itself, so we're just simply going to multiply 27 times cosine of 48 degrees and get that x is equal to 18.0665. Again, we're rounding to the nearest tenth, so we're rounding to this place value right here. And if we look to the right, this 6 is greater than 5, greater than or equal to 5. So this is going to go up to a 1, and we're left with 18.1 for x. Okay, that's your quiz. That's similar to what your test will look like. The only other thing is that you're going to be given a triangle, and you're going to be asked, what is the sine? What is the cosecant? What is the cosine? What is the secant? What is the tangent? What is the cotangent? So if you're given a triangle here, and you've got x, y, and z, and we pick some values. Let's just go back here and say we've got 20, 21, and 29. 20, 21, and 29. We can say that the sine of x would be the opposite side over the hypotenuse, so 21 over 29. So we know the cosecant of x would be the reciprocal, because cosecant is the reciprocal function of sine, which would be 29 over 21. Next, we've got the cosine of x, which is the adjacent side over the hypotenuse. So we've got 20 over 29. So the secant of x is the reciprocal of the cosine function, which would be 29 over 20. And then we've got the tangent of x, which is opposite over adjacent, so 21 over 20. So the cotangent of x is the reciprocal function, which is 20 over 21. Okay? I'm going to ask you to do the exact same thing for the y's. Cosecant of y, cosine of y, secant of y, tangent of y, cotangent of y. So the sine of y is going to be the opposite over the hypotenuse. So we've got 20 over 29. So the cosecant of y would be 29 over 20. The cosine of y is 21 over 29. So the secant of y is the reciprocal, which is 29 over 21. The tangent of y is opposite over adjacent. So the cotangent of y would be 21 over 20. Okay, so that's similar to what your test is going to look like. I look forward to lots of great grades so we can see some improvements. So thank you. Have a good weekend.